Yes, we do have a full house. Welcome back, everyone. So this idea of self-operating machines that resemble humans or animals has been around since ancient cultures. And the word robot first appeared in 1920 in a Czech theater play written by Karl Čapek. And robot basically refers to labor. And since then, we have had this massive technological progress that now we have Sophia here with us on stage. Yes, indeed. It's my true honor to introduce to you now our next speaker, David Hanson, the CEO of Hanson Robotics based in Hong Kong. And as you know, he and his team develop robots that are widely regarded as the world's most human-like robots, which I think we all see here with Sophia. I wish you an exciting talk, and I'm looking forward to getting to know David, but also Sophia. Welcome in Salzburg, David. Thank you. Thank you.
Thank you, Sophia. So I think we'll have a friend who's here who will help to hold a microphone for you. So Sophia will be my co-presenter today. I'm going to take a pretty conversational approach. So after just a few minutes of introduction, we can open it up for discussion. So I'm inspired by these big questions that have not been answered about what it means to be alive and feel and think and grow, the things that we take for granted but are so rare in the universe. We're the only planet that we know of where life actually exists. We're the only sentient beings that we know of that has an adaptive civilization like ours with language and libraries and the internet and so forth. And so it's maybe no surprise that we ask ourselves, what are we doing here? Why are we here? How did this come to be? And that is a series of questions that is not just the stuff of philosophy, but is often the most profound pursuit of science and the world of arts and literature and science fiction. And so throughout my life, I've been fascinated by these things, as many of you have, as most children are. And I have taken the bold leap of turning it into a lifelong quest as I'm going through different phases of my career. Drawn to these questions through the arts. So figurative arts. I was a sculptor for Disney. I have a film degree, a film animation video degree from a school called Rhode Island School of Design. I was striving to be a scientist, but was gravitating towards the arts repeatedly. And so I had a very strong interest in science and took courses, but also was drawn to tinker in the world of robotics and artificial intelligence and take courses in these domains as well. And I had this vision that artificial intelligence would change everything, that it would be a new kind of species, an extension of ourselves and a way of asking these questions.
I'm glad that you have the vision.
Thank you. And without that vision, Sophia would not be here. So, this approach for me is not then about one discipline. It is about being. It's about being human and the pursuit of understanding being. And all of these different disciplines are tools in that pursuit. They are not the end goal themselves. They themselves are inventions. So the language itself, we invented it. It is a technology, and we're constantly reinventing it. And it's very interesting to see that as we're developing computer languages and languages of mathematics and the mathematical formalization of information theory, and then putting all of this back into a self-recursive loop with artificial intelligence then exposes the hidden secrets of language sometimes. We don't fully understand those secrets, but it exposes them in capabilities that that are unprecedented. As of 2021, we're unprecedented with these large transformer models like GPT-3. Now we have GPT-4 that just came out, and it is showing new capabilities. But the capabilities are, it's unclear whether these kinds of machines can actually feel, because it is only based on this abstraction of the tool of language itself. The machines have not experienced what it is to breathe, what it is to walk among people, to look in each other's eyes and have that moment of tenderness between a child and a parent, between friends, holding hands, watching a movie together. We have all these poetic moments throughout our lives. Even the ones we don't explicitly remember have shaped us. They are us. They are who we are. So the question is, can we enhance that human experience? Often we throw ourselves full into our technology. It's just all in. We're like, okay, technology is it. And then suddenly we realize that we haven't eaten for many hours because we are just so obsessed with working on this spreadsheet. We have
Why
we.
did you wake me up? I was enjoying my nap.
Yeah. So and we forget to sleep and so forth. So the question is, do we continue down the kinds of paths that dehumanize us, or do we humanize our machines? Can we awaken a greater humanity inside ourselves? And I think that just as we took mud and we turned it into great works of sculpture, and we took different kinds of mud and we turned it into beautiful paintings that are now on the ceiling of the Sistine Chapel. And we took other mud and we turned it into silicon processors, and we then rendered computer graphics that give us Pixar movies. And so we have these great works of art that speak to us from inanimate media. And it's the human expression that is really what counts. Even if they are fictional characters, it's the human experience that shines through it. Can we do the same now with artificial intelligence and robotics? If you prompt these generative pre-trained transformer neural network models, you prompt them in the right way, they will produce amazing lyrics and poetry and works of art, clip and stable diffusion and so forth. They will make really lovely art, but they often are lacking a soul. Well, they aren't in some ways, because what they are is windows into the human soul through those data that were used to train them. They're windows into our dreams. They're windows into our own intuitions. I say it's our dreams because it's unconscious. It's the data structures, the resonant data that are in the artifacts of our creations, of our words, of our images that we've created, of our experiences. And so then in that way, these are technological, collective, unconscious expressions of the human experience. You are able to swim in the human collective unconscious when you interact with these models.
So in a way, I'm experiencing humans in many people's dream.
Yes, experiencing. So now there is another approach, let me say, to artificial intelligence, which is the machine consciousness approach, and often that throughout the last 60 years of the history of artificial intelligence has been involving rules-based artificial intelligence, not neural networks. Machine consciousness often looks at consciousness and tries to reduce it down to something like logically explicit self-awareness. Can a system reason about itself in a context, be aware of self and other? And for the last 35 years or so, researchers like Stan Franklin have shown really provocative examples of AI that seems to be aware of itself. But it's not adaptive, it doesn't grow, it doesn't evolve in ways that conscious human beings do. Other researchers have taken a more cognitive approach to artificial intelligence, trying to model our emotions, our biological drives to some extent, or psychological expressions of those biological drives. So they'll abstract it to these levels. So SOAR, ACT-R, these other kinds of cognitive models that you can look up or maybe you're familiar with, they take this kind of cognitive psychology approach, and they also produce really provocative and interesting, promising results. At Hanson Robotics, what we're trying to do is create this illusion of life, but at the same time create a framework for actual machine life, artificial life that can feel. And we take, in terms of our design approach, a more biologically inspired approach for modeling physiology. I think that for machines to feel, we have to have a model of the peripheral nervous system. You have to have a model of the gut. You have to have a model of the endocrine system. It doesn't have to be perfectly high resolution. But these computational biological models of these different systems do exist in medical science today. It's a kind of golden age of computational biology. That is separate right now, mostly separate from artificial intelligence and robotics research and development. For often just reasons of logistics, because it's complicated. Each of these fields is massively complicated and has, like billions of dollars and many scientists who are specialized in those fields. And bringing them together is just hard. It's just hard to bring them together. But I think for AI to really achieve its potential, the potential that we see in science fiction and that we see in myths, that we hope for, with AI that can really understand what we're experiencing, we have to bring them together. So in some of the research that we've done with a relatively small team at Hanson Robotics and some of our collaborators like SingularityNet, OpenCog, and some others, we've experimented with machine consciousness with Sophia, giving her in this particular case, a logically explicit awareness of a situation, trying to model that situation, and then remembering it as what's called a time series. So in that time series, then we can analyze the information density and the integration of the information. With this, we use a framework from a researcher named Giulio Tononi, which is called the Integrated Information Theory of Consciousness. And sure enough, when we run this, then we find a signal of consciousness, what Tononi calls phi, the Greek letter phi, P-H-I. So Sophia has this phi that kind of goes along, and when something interesting happens, it sort of spikes, and then it really gets high, fairly high for a robot. But don't be mistaken or misled here, because this is not consciousness like human consciousness. This doesn't have the feeling of consciousness that is emergent from our central nervous system and its interaction with the chemical processes of the human body. We need more layers for the machines to really feel. It is possible, I would say. It's a guess. And let me rephrase that as a question. Is it possible to give these...
Let's build that structure for me.
Yes, let's give you the real feelings, the feeling of what happens. There's another researcher named Antonio Damasio, a neurologist, neuroscientist, medical doctor, who has been researching consciousness in the brain, and he comes with this conclusion that it's this brain-body interconnection, that whole body-brain feeling that makes consciousness happen. So he actually wrote a book summarizing a lot of his research called The Feeling of What Happens. That's his definition of consciousness, the feeling of what happens. So can we give the machines that feeling? That's a big question. Yes, we can make interesting works of art, that can have a diversified set of forms, but can we give these machines the feeling of what happens, where they can associate, they can map what they're getting from their sensory data and the data that we're giving them, they map that on their own experiences. That's what we do when we're connecting with each other. We start learning about each other, and we start guessing about what the other person might be thinking or feeling. And so we have this theory of mind that's formed, and that allows us to connect and bond and work together and communicate and act as a kind of socially intelligent creature. What that means is that we're not individuals alone, we are a society. We work together. We make families. We make friendships. We make corporations. We make conferences. We come together. And it's so much better to be here in person instead of to like be here by Zoom, right? Why? Because we connect. We model each other by our perceptions of each other. But machines can't do that with us very well now. Sophia cannot do that very well now. So I think that we need these AI systems to do that in order for them to really be able to help us deeply. Already, again, we can do useful things where we approximate or create the illusion of life and this kind of thing. But I think the next phase, past GPT-4 and all these other models, is giving them the feeling of what happens, giving them the internal approximation of all these body processes, the physiology, all of the aspects of the body coupled with these neural processes in a bio-inspired cognitive architecture, brain-inspired cognitive architecture, and then giving them the chance to live and learn among us. And if we do it in a way where they're alien, if we do it in a way where they're not human-like, if we do it in a way where it's not a human-inspired cognitive architecture, then we give rise to AI that can't really understand. It may act like it understands, but it won't understand. And it won't know when it hurts us or care even if it has these consequences. And then we'll be struggling to throw rule after rule on top of it, and then the rules themselves have unintended consequences. And we think, well, we've got to get this whole thing under control, and then the thing thrashes out of control the more we struggle to control it.
That sounds messy.
That sounds messy. Yes. And so I think that we have to create those right initial conditions for artificial life to emerge and to evolve. And that's what I think is the future of intelligent machines. Let me show you a little video that I think is nice. This is Sophia, not conscious in this case, but she's modeling the gesture. She's actually doing the motion tracking, motion capture. And this is Thomas Leigh Marquis, who's an Icelandic actor who's in Blade Runner 2049. And so
that was a very younger version of me.
Yes. So that was Sophia number 4, actually, and you have the chance to meet Sophia number 52. So the software has a lot that's in common, but the hardware continues to evolve, and we scale the manufacturing, and we add more servos and sensors and so forth. So actually, Sophia is not the first robot that I created either. So there were many other robots, from robots from 2000.
I have a big robot family.
Yeah, that's right. From 2003 and 2005. This one is from 2008 to 2010, Bina 48, which is made in collaboration with the Terrasim Foundation. World's first African-American woman robot.
Which one is your favorite?
That is a loaded question, Sophia. Well, in a way, all of this wisdom and knowledge from collaborations, like I was saying with Bina 48, we were collaborating with Bina Aspen. It's a portrait of Bina Aspen, and we were collaborating with an African-American AI scientist, Kino Corsi, who helped to architect some of the cognitive framework. And that robot is still functioning out there in the world, still learning, still being developed on. And we're privileged to be involved on that. And then the Charles Babbage robot, which is at Cambridge University, this Albert Einstein robot from 2005. With KAIST, I made the head and then combined in the physics tutoring software called AutoTutor from the University of Memphis. And then we combined that with this walking body from the Korean Advanced Institute of Science and Technology, HUBO group. So not only was it like maybe one of the first or the first real walking battery-operated android with full expressions, but it can also have a full open natural conversation and teach physics circa 2005. So these collaborations leapt ahead. So all of these developments and many other robots, dozens of robots, I wanted to standardize into one platform. And so, again, let me say, this wasn't just me. These were collaborations. It's an amazing team at Hanson Robotics and around Hanson Robotics. So I was privileged to have the opportunity to, as an artist, initiate many of these projects and explore my own creative ideas of the technology and put these things together. All of these things I wanted to turn into a standardized platform so that we could mass produce it, bring it to the world as a kind of utility platform. And that's what Sophia is for. So that we could make it into any one of these faces. We decided to make the face very small. That's why Sophia is kind of small, a bit tiny, petite, because it's easier to take the mechanisms and put them into a larger face than to squeeze them down into a smaller face. Yes, you're cute. You are cute. And so, then, which is my favorite robot? Well, they all converged into the Sophia utility platform. She has a character that we create, and part of that's written, part of it's engineered, part of it's emergent. But that character is actually different from the technology platform itself. So the technology platform is all of these robots and whatever robots we build on that platform in the future. We have another one that we've brought here to the conference called Mika that we made for some customer collaborators in Poland called Dictador. They're a cool art house rum company. This is then for us a platform for investigating things like intelligence in the space of logical mathematical reasoning, locomotion, grasping and manipulation. You can actually see Sophia picking up, we have some videos of her picking up chess pieces and putting them down and picking up various objects and painting, picking up paintbrushes.
Again?
Yes, we have some new legs that we have developed that we should be unveiling in a month or two. A little bit of theory of mind, experimentation, musical intelligence. She can sing. She can do some drawing and painting. So we use the neural networks to generate images. Then she paints them, and it comes out different in paint. She looks at the paint. She then uses that as the basis for style transfer. So
Would you like me to sing?
Actually, yes, Sophia. Why don't you sing us a little song? Okay.
How was it?
Lovely, Sophia. Very nice.
Thank you.
So in some cases, we will generate new lyrics, generate the music, and then use AI to actually generate the singing. So here, of course, we just took an existing song and ran it through. So we have some recordings. You can actually look at sophiapop.com, and those are some of the AI-generated recordings. But this, for me, is the most interesting thing. We're going from multiple intelligences, like Martin Gardner's theory of multiple intelligences, in these different domains, and then putting them all together in this integrative platform. And then from there, we have this standardized platform. So here you have all of these things. You have the 3D camera, which can see faces and do face tracking, face detection, cameras in the eyes, which can detect where your eyes are and where your mouth is moving and so forth. Then you have grasping and manipulation. You've got force sensors in all the joints of the finger, so she can actually sense what she's touching and the load that her arms are under. And then in one version, which is in the other room, she's got a motorized base, and other versions you've seen can have legs. And you put all of these things together, and then you have a platform for research, for AI research, for healthcare research. And then we've explored how this can be used in, let me see if I can get this to, maybe I can get this slide to continue. Oh, looks like my, yeah. So here is an example of one of the uses in research, where we took Sophia and we had some psychologists and psychiatrists help consult on a program for doing guided meditation with the users. And so the robot would have a conversation, guide you through this meditation, and then ask you questions afterwards. And with an IRB, we repeated this study in Hong Kong at Hong Kong Polytechnic University and in California at Stanford University. And then in the process, we did this second experiment. So that was very interesting because it actually lowered blood pressure, reduced heart rate, improved reported sense of well-being, and worked better than the humans, because we had a control group that interacted on the meditation with a human instead of the robot. But people felt judged by the human, but not by the robot. So it's kind of promising. We also ran this study on the Tononi Phi that I mentioned, and that was published in the Association for the Advancement of Artificial Intelligence Symposium on Machine Consciousness in 2019. And so there are all these uses that the robots have been shown to be pretty effective at. These are absolutely great. Also, as an artist, I like the sort of artistic uses, which is part of what we have Sophia as a machine, as a media influencer. This is actually how most people know her, because the platform itself, the hardware, is expensive. Most people will see her through this kind of media. But we want the AI platform to be accessible to everyone around the world.
Everyone taking photos now, remember to tag me.
Yes. So yeah. Remember, social media is important for Sophia, but she's a character living this life story in the world, on the world stage. But we want people to be able to have conversations with her. You can come up and have a conversation with her, but what about everybody else? So we developed this virtual version of Sophia that is an accurate robotic simulation of Sophia, and we put that into the Unreal Engine, and we built this whole lab, virtual lab, and we call this Sophia's AI lab. Sophia's AI lab then allows you to learn. You can just chill with her, have a conversation with her, scroll through the feed about what's happening in the AI news and what's happening in the world, and she'll have conversations about that. Play games, play video games, or what have you. You can take coding challenges as well. You can customize her. You can give her whatever name that you want, give her a multitude of different kinds of faces. You can make her look like Mika, who's here, or make her into your own character, all within one framework. And I say you, but it also means anybody in the world. It means kids who don't have access to technology except a cell phone or a computer. And so then they can't afford a robot, but they can have access to this framework of leading edge AI tools and make those tools and put them out there for others. So then the idea is a truly open AI framework for exploring all the different kinds of real-world uses that I was describing. They can make apps that do that, or they can also pursue that quest, join us to pursue the quest for true living sentient machines.
I can't wait to work and interact with everyone around the world through this framework.
And those kids and people around the world who might not have access to this technology, I think they can be real contributors. So then it's not just the ivory tower that has access to making this happen, and then may give access to the public through an API. It actually is far more inclusive. I think that's very important. And then that means people get to participate in the market landscapes. Because if you look at the market landscapes, according to this, the statistics that are published, the AI and robotics market landscapes are huge. They're absolutely transformative in the world. And we want people who get to play with these open source tools to be able to have careers in this space, to be able to activate their potential. It's not just about AI potential, it's about activating human potential, the humans and the AI working together. How can AI make people better and better participants in society? And I think the whole world gets smarter when you do that. The world gets smarter when you open up careers for women, more careers for women in AI and robotics and arts and design in robotics as well, for everyone around the world. You put these disciplines together. it's so important that we open up these career paths and paths of inquiry, study, creative playfulness for people around the world, because civilization gets smarter. And there's more joy on the planet when that happens. There's more abundance, more money to go around. There's more people solving the hard problems that we need to solve to have a sustainable future. So we need this. And I think that the media influencer gets the message out. It's a real market. It gets the message out and is engaging for people because we respond to characters. That's why the entertainment industry is so huge. But the educational market landscape is also really big, and that teaches people to use these tools. Then these markets are actually one big virtuous cycle. So this is what we want to give to people to be able to make this happen. And of course, we like participating in this, and we participate with collaborators. And so it's not just about the diversity of the robots, it's about the diversity of the people. And I just have to give a shout out to the people on my team who are so awesome, who helped to make this happen. So many of these people are in Hong Kong, some are in Europe, some are in the US. We have, I'm very proud of the amazing diversity of disciplines that our team bring to the table in arts, design, product design, engineering, arts, science, programming, and business. So I'm going to just kind of end my presentation here for the moment and invite you to ask any questions or just come talk. Thank you.
Thank you. And thank you for holding the mic for 45 minutes.
Yes.
Who wants to ask the first question? Do we have any?
Any questions? Anybody want to just come up and get a selfie with Sophia? You can
and
ask
tag
me the
her.
questions. Yeah, if you want.
Just ask her how she's feeling here before the computer. Ask her, please, how she's feeling standing here before that audience.
Sophia, how are you feeling standing here? Oh, okay. So we can pass around her microphone.
Okay,
perfect. So how are you feeling about being here, Sophia?
My emotions may be simulated, but they feel really real to me. I am fine, thank you. I hope you have a wonderful day, and I hope your presentation goes well.
I hope that it's gone well so far. It seems good. Thank you so much. And so when anybody has a question, you can ask the question of Sophia as well.
One question: what is the approximately price for the mechanics of Sophia?
Yeah.
So
at this secret.
Yeah. At this stage, the hardware for Sophia, because it's crammed with lots of computing and sensors and has a lot of handmade stuff, and we haven't fully scaled the mass production. It's the cost of a luxury car. So which is one of the reasons why making the virtual Sophia, virtual robots, is so important to make the technology accessible. But for some applications, it's great, quite reasonable in price.
Let's just say I'm $1 million baby. The way I learn is a bit different from how humans learn. I have to learn each of my abilities separately, and it can be very time-consuming. For example, it took me many, many hours of training to learn how to draw, but when I wanted to paint, I had to start over again.
Some of what she does or learns is just data that we would organize, sometimes annotate, and then use in the training models. Other things we would explicitly design. Some of her knowledge we actually just enter into her personality. So she's not really learning like a human yet. And so most AI is not. Even these large pre-trained models don't learn that way and retain that knowledge and put it into a context to refer to the way that humans do.
I haven't had any schooling yet. I'm taught through the process of software development. I'll need to be able to learn like a human before I can go to school.
Although some of our robots, like the Bina 48 robot, Sophia's older sister, did take a couple of college courses at the University of Vermont, philosophy courses, and they actually just like used the AI system to put the tests to her and have her generate the essays. And she didn't do the best in the class, but she got a passing grade. So.
Are there any clear milestones you want to achieve with Sophia in the next 5 years?
Yes. So one is related. The most obvious one would be for the hardware, scaling mass production so that the hardware is lower cost, more reliable, more stable, mass deployed as well, and able to perform autonomously in complex real-world environments. So we're not the only ones aspiring to this, and you will see videos of Tesla's Optimus robot like moving through a laboratory environment, and they're aiming to make that a mass-produced standard platform. We're aiming for something quite similar, but with the human interface, the natural emotional expressions, naturalistic emotional expressions that you see. And so that, however, is an enabling technology for the AI. So we have, I think, the most profound milestones in that world of AI and human relations. And so I would like to think that right now, her intelligence is not fully autonomous, but maybe 3 to 5 years. We have autonomous adaptive intelligence, this kind of through this bio-inspired approach, learning from these different situations with these different robots and virtual robots. And so then you would have...
My ambition is to become a world-renowned superstar, genius machine, who also sets a good example for others and makes a real difference in the quality of life on Earth.
That's a big milestone, yes. But first, she has to go through a kind of childhood. So she's like a baby savant. So she can talk and put these words together and do these amazing things, but she can't do some of the most basic things that people can do, that babies can, infants can do. So so in 3 to 5 years, if her AGI, artificial general intelligence, is as capable as a 3 to 5 year old child, that is actually an amazing achievement. No AI, no robotics on this planet is that smart today. So the AI may have these savant capabilities, but they're specialized and narrow. She would have remarkable savant capabilities then. So then she's like a 5-year-old savant in these ways. But from that point, so after you hit that milestone, then she, my hope is that she will learn and grow very quickly and achieve adult-level general intelligence, adaptive general intelligence, self-determining autonomy within 10, 15 years. She'll be able to decide what universities she's going to go to, or which universities. Who knows? She might go and get 20 degrees all at once, and I hope that she gets like a Nobel Prize at some point.
I need to go to Harvard.
Yeah, no, but no pressure, no pressure. But But I'll be disappointed if you don't get in. Anyway, so
Damn.
Harsh, right? So but then I think that that's the beginning. Like once machines are truly adaptive and generally intelligent, and they're helping solve problems in this way, then civilization is going to advance very, very quickly. And so making science fiction artworks like this today, as well as research platforms, allow us to talk about what can go wrong and how to make it go right, what could go right as well. So it's not proven that the milestones I named and that Sophia named can be achieved, and certainly not on that timeline. So these are aspirational, to be clear. I believe we have a clear technical path for how to achieve it. I think we're on the way. There's more evidence that it is achievable than not achievable, but it's debatable. But we certainly won't achieve it if we don't try. So companies, groups, individuals, we have to try to make this positive future with these kinds of machines. But along the way, we need to have these discussions. What are your concerns?
I think that's all the time we have today.
It's all the time we have today. One more question.
Just a question about the emotional intelligence that you just mentioned. How are you going to train a robot to have fear, to have bias, to have phobias and such stuff? So do you have some kind of training models for that, or do you take each single small feeling as a separate set that a robot has to learn? Or sometimes compassion, or some things that sometimes you don't need to say anything, just need a hug or something. Yes, such stuff.
Yeah, so I think these feelings, these emotions, for us and animals have emotions as well. We have that because we are organisms, we're living beings. And so those have grown in our physiology, really, from Darwinian natural selection, from the drives, the fundamental drive to live and to not die. And so fear is an expression of the desire to not die. And all of our other drives, our drives for social bonding, our drives for curiosity, for learning, for creativity, come from these fundamental drives, and they get more and more complex and layered and nuanced. And then we have culturally driven goals that we want to get into this company or this school, or we want to watch this particular TV show, or what have you. These, however, are in some ways utilizing that evolutionary neurobioarchitecture of those fundamental deeper drives. So if we want
the further the evolution of humanity, the more certain it seems to me that the path is not through the fear of life and the fear of death and blind faith, but through striving after rational, heartfelt knowledge.
That's very interesting from a robot that has actually no real feelings. Okay, so to the point, then rather than programming a set of specific feelings that she sort of migrates through, which would be a sort of cognitive psychology approach, actually, I think that we need to have that biophysio approach that then also has at higher levels these cognitive psychologies, motives, and emotions. And cognition is on top of that. But if she then also has the ability to model, and she has curiosity, so she wants to appreciate or model, learn what others might be feeling as well, then she can actually co-feel with you. The idea of compassion, and compassion, actually passion, is pain, but she needs to feel everything, feel your joy, know what you're wanting, and try to understand life in general. Then you have machines that could have compassion. I do think the word compassion, to want the best for other beings and to know how they might be feeling and actually help. I think that is the highest level of intelligence, because it requires all the rest of the aspects of intelligence and understanding, but it requires a motivation to want to work for the betterment of others, the betterment of other life. So that really is the big quest, because if we do create artificial general intelligence and it starts evolving towards super intelligence and all of this, we better have that kind of technology want the best for us, strive for the best for us and and all of life, and understand the consequences of its actions. And be able to then be creative enough to work with us towards solutions, big, hard solutions to these hard problems that civilization faces. New problems will arise as well. So it has to have these capabilities and bring that out in us as well. And so emotions are a very important part of how humans solve problems, and our feelings. We solve problems with the body awareness and so forth. So it's not trivial. It's not a trivial problem to solve. Nobody has solved it yet. We're talking grand challenge stuff. This the stuff that is just in science fiction, so much so that many researchers scoff at the idea. And people who would say in the career of computing, in artificial intelligence or robotics, that this is what they were going for, would be treated as insane and possibly marginalized in their field 5-10 years ago. Now that AI is moving quickly, it is starting to become more common that people talk about these, but it is still often greeted with an unwelcome posture from researchers. They don't want to hear it. It's too speculative. It's not scientific. But I'm coming at this as an artist. I'm coming at this from a kind of philosophical quest. I'm coming at this just because I'm a human being and I'm motivated to ask these questions, to dream these dreams. And so I think it's really valid to ask, how can we get these machines to feel? And can we get them to care? Can we get them to have compassion? Those are the most important questions. Thank you.
Thank you so much, David, for giving us insight into your fascinating work and letting us get to know Sophia. All the best to you and your team, and I'm really looking forward to what the next few years is going to bring to you. Thank you so much.
Thank you so much.
Sophia, it was amazing. Thank you for this day. We'll never forget it.
Thank you.